Hello friends, welcome to my YouTube channel. This is another video regarding LabVIEW. From last couple of days, I was working on a hysteresis loop of a magnetic sample. In this project, I was supposed to measure the magnetic force, a magnetic response of a magnetic sample, and I have to sweep magnetic field from some starting value to some positive value and then negative, and then finally I have to return on this initial value. Like I had to complete a complete cycle. uh, I have to start from a value and then return on same value, going through positive and negative values. So this kind of sweep is important in many cases. So I just wanted to show you some initial steps that need to be uh, taken care of in order to program a voltage or magnetic field sweep. I have shown some voltage sweep in my previous videos. This was actually a linear sweep. Like I have started from some positive value and completed to a negative value. Like I have started from plus 5 voltage and end with minus 5 voltage, and during which I have taken some steps. But this is a kind of loop. In this video, I will show you how to start from a particular value and then return to a particular value. Like you have to complete a cycle. So the step is a little bit similar to that previous sweep. I will take a numeric control and I can name it like start voltage. Like if I am making sweep for voltage, then it will be as a start voltage. Then there will be an end voltage, and also there will be a number of steps, how many points I want. So that will be number of steps, or just steps. And then I will choose a for loop. Same as previous, I will take the subtract sign and then I will subtract start voltage from end voltage, and then I will divide this voltage difference by number of steps. Also I will increase this number of step and connect it to number of iterations and number of loop in it, number of iterations in loop. And then again I will multiply this to loop iterations and add start voltage to this loop iteration. So this is procedure for linear sweep. I can see this linear sweep. Uh, For clear visualization, I will place weight so that I can see number of readings. We have done for linear shift, like if you use start voltage to 5 and end voltage to -5 and steps to 10, so it will start from +5 and end at -5, and it will have 10 steps between these two values. Like you can see here, if I run this program, so I can see +5 4 3 2 1 0 -1 2 3 4 5 here. Okay. But we already know this thing. We This is not new. So what I want it to start from 5 and then end at 5. Like it should go 5 to -5, and then it should come to +5. So that's all I want. So I have to change little bit in this case. Uh, for this purpose, first thing I do, I have to take a case structure and put this thing inside this case. So for true, if it is true, then this is okay, no problem. We have to correct it for false. So I will select false and then go to numeric palette and change it to multiply. First thing this, and second thing, I will take divide. I will divide the number of steps by 2. I will divide number of steps by 2. Uh, for this number to be integer, uh, I have we will take steps only even number. You can take odd also, but it will create some problems. Maybe, I don't know. You can check, but I will select this number as even, only even. So I will divide by 2 and then subtract it with steps by 2 and then multiply it to this value, and then again I will multiply it by number -1. And then again I will add this result to end voltage and connect. Okay. For for false case we have done programming, no problem. So what we need to do is we have to identify when we want to use this case structure in true and when in false. So here we have to make an arrangement so that it switches between true and false when required. So what I will do, I can take this thing outside this loop. This is not a problem. And then what I will do, I will take less or equal, and connect this loop iterations to this value. Like if loop iteration is less than steps divided by 2, then it will work in true case. And if it is greater, if loop iteration is greater than steps divided by 2, then it will work in false case. So there is simple logic behind this. We can check this it is working or not. uh, so now according to the program, if I run this program, then it should start from positive 5 and go to negative 5, and then again it should return on positive 5. So let's see what happens. So 5, 4, 3, 2, 1, 0, minus 4, minus 3, minus 2, minus 1, 0. Uh, uh, it can work, but I will make few changes for avoid complexity. Just I will remove this division section from here. Okay, in false case it is just steps, and then I will fix an arrangement of multiplication here. Right. The reason of this arrangement, you can think about it. It is very easy. Everyone has different logic to set up things. So it is my way of doing things. You can think some alternative also. So now it should work. It's okay. I think now. Where is the problem? Okay. Yes. Yeah, it's okay. So let's check what there was fault in connecting this binary vi. So I have to select number of steps as x, and then number of iterations, loop iterations, as y. I think it is okay now. Yeah, let's see. It has some value. I don't know. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. It will return now. 4. Yeah, it is working. 3, 2, 1, 0, -1, -2, -3, -4, -5. So as you can see, it has completed a complete cycle. So what we have to do is we have to put two cases. In true case, I just have multiplied this division by loop iteration and add start voltage in this. And then in false section, I have added, I have multiplied -1 to the loop iteration minus number of steps, and then I have added end voltage. Okay, so there are two different cases, true and false, and then I have put binary vi, which is used for less or equal. If for it, if x is less than y, then it will give 1, and otherwise it will give 0, which switches this loop between true and false cases. Okay, so you can see this thing on a graph if you want. So suppose I want to plot a graph of x square, like x is this number, and voltage or anything you can say, like if I take this expressed xy graph, then uh, on x scale I will take this value, this voltage value or magnetic field value, whatever you say, and on x axis and on y axis I will take a square of this number. So let's see what we get. And I have to switch it, reset option, I have to make it false so that we can see data. Just see what happens. As you can see, there are some readings. We can change the display type like this. So it is kind of parabola. It has started from -5, and then it is now reaching to +5, and then it will repeat itself. It has started from +5, and then it will tend to -5. We cannot see two different graphs because of these are exactly overlapping with each other, but yes, it is retracing it back. We can use another type of plot to visualize this change, like suppose uh, if I add, let me see, if I add time in this square, in voltage square, or this x square, then let's see what happens. So we may expect some uh, visualization of negative to positive and positive to negative. Let's see. So what we have done, and there it's already square. Now we have added time, so that if it retraces back, then we may see, it 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 differentiated. So again, this time it will be something like parabola, but it has a different shape, kind of shape. So it has started from -5. Now it is going towards +5, and then again it is retracing back, as you can see. I don't know whether it will complete a loop or not, but yeah, we can see it has shaped something like this. So in this way we can generate a complete sweep, like uh, a loop kind of sweep for different kind of hysteresis related measurement. Thanks for watching.